Our lesson today is going to be about multiplying polynomials. Now, last lesson we learned how to multiply a monomial, which is just one term, into a polynomial. Or basically we were just distributing a term. So today we're going to use those same ideas, but we're going to be starting by learning how to multiply two binomials together. So the thought is exactly the same as last time when you're multiplying different terms. There's just going to be more to multiply this time. So if you look at the first example, it's exactly what we said, multiplying two binomials. So this first set of parentheses has two terms, and so does the second set. So binomial, two terms. So that's what we're going to be doing to start. Now, to do this, we need to multiply each part of the first binomial, which is 2x plus 3, by each part of the second binomial, which is x plus 4. So these two terms need to be multiplied by these two terms. So basically, that's going to leave us with 4 different terms or 4 different things to multiply. Now, you probably, I feel like in biology, you guys FOIL. You can use what's called the FOIL method to multiply two binomials, like this example. This is just an acronym, so that means like F stands for something, O stands for something, and it just helps you remember how to multiply two binomials. And keep in mind that FOIL only works when each polynomial has two terms. If there's something like this example here, where one of the polynomials is a trinomial, it has 3 terms, FOIL doesn't work. Okay, so if you have never heard of FOIL, you forget what it stands for. F stands for first. Basically, that just means come to your example and you multiply the first term in each group. So that would be 2x and x in this specific example. O is for outside, so the terms on the outside, so that's 2x and 4. I is inside, which would be the terms on the inside, and that's 3 and x. And then L stands for last, so that would be the last term in each group, so 3 and 4. Honestly, yeah, you're essentially doing foiling if you think of it like I do, but I just think of foiling as really just like extreme distributing. And that plays off well of what we did last time, because last time we just had a monomial out front, like the 2x, and we just distributed that through. So all that's different here is that not only would you have to distribute the 2x, but you'd also have to distribute the 3. So I'm just going to think of foiling as whatever terms are in the first group, I just need to distribute all those terms to the second group. So let me show you what I mean by that, and let's go ahead and do this example. So the first step is just to multiply each pair, so first, outside, inside, last, each pair of those terms together. Now, let me copy the example back down. X plus 4. You have to keep in mind what we talked about last time. So if I'm multiplying something like 5x squared times 6x to the 4th, obviously I'm totally making this up, but remember when you multiply terms that you multiply the big numbers, so this would equal 30, and the big thing that you have to remember is that you have to add the exponents to bring the x's together, so this would be 30x to the 6. Okay, so don't forget to add the exponents. That's probably the number one thing people mess up on this. So you're going to multiply everything through. Like I said, I just think of foiling as distributing, but use the acronym if it helps you. So I do the first terms, so 2x times x, and I'd put 1s in there on the x's, so you don't forget to add the exponents. And there's a 1 in front of this x right here. So when I multiply these two terms, I'm just going to multiply 2 times 1, and then I'm going to add the 1s to get x squared as my new exponent. Then you're going to multiply the outside terms. Basically, you're just distributing 2x to both of these guys. 2x times 4, all you can do is multiply the numbers and then just bring the x down. Then you're going to multiply the inside terms, or guys, you're really now just going to distribute 3 to the second group. So 3 times x is just 3x, and then 3 times 4 is just 12. So when you multiply two binomials, you should have 4 terms after you do that. The second step, though, is you need to see if you can combine anything. And I would say like 8 or 9 times out of 10, you can combine stuff. And it's usually the middle terms that can be combined. Those are like terms. They're both x to the 1s. So I can add 8x plus 3x, and that would just be 11x's. So if I just bring everything else down, that's my product. That's my answer when I multiply. All right, let's just do a few examples on the back here. Honestly, it's kind of the same thing every time. For example A, and notice the directions say, make sure you write your answers in standard form. Don't forget that part. On this next exam, quiz, whatever, every answer should always be in standard form. All right, FOIL, got two binomials. I'm just going to think of it as distributing. So the first term in each group. So the first term in the first group is x, and I'm going to distribute x to the second group. Okay, be careful. X times x, you're just doing like 1 times 1 in front, which is 1. You really just have to add the exponents. So x times x is x squared. X times negative 8, if it's just a number and a variable, you kind of just like squish them together. And that would just be negative 8x. Now I'm going to take the negative 6, take the sign with it, and I'm going to distribute that to the second group. So negative 6 times x is negative 6x. Watch your signs here. Negative 6 times negative 8 is a positive 48. Be careful with your signs. Then I can go ahead and put those x's together. So negative 8 minus 6 is negative 14 x's. Plus the 48, that would be my answer. All right, I want you guys to go ahead and try example B. Now, the rest of them, I'm going to make a little note here. Honestly, it's not really necessary to note this, but these examples, C, D, E, and F, they're what's called the special cases. And I'll kind of show you why as I go through them. You don't have to know that these are special. I'm not going to ask you to tell me that, but it's good to point out that there's something unusual about these. But really, especially on like C and D, you're just going to do the exact process I just showed you, foiling or extreme distributing. So watch what I'm going to do on C here. So I'm going to take the x and I'm going to distribute it to the second group. So x times x, again, that's x squared. X times 5 is 5x. Then take the negative 5 and distribute it. That would be negative 5x minus 25. When you go to put the x's together in the middle, because you can combine those, negative 5 minus 5, that's 0 x's, so I'm not even going to write it. That's why this is a special case. The x's go away, and it's just x squared minus 25. Again, it's not necessary to know that that one's special, but just be aware they call that one special for some reason. All right, on example D here, same thing. You don't have to think too hard. You just got to like FOIL this out, distribute. So 2x times 2x. That's 2 times 2, 4. Add your exponents, 4x squared. 2x times negative 3 is negative 6x. Okay, then distribute the 3, so that would be 6x minus 9. Again, this one is special because when you go to put the x's together, negative 6 plus 6, that's just 0 x's. Not that cool, but it's a special case. These last two, and you can kind of tell right off the bat why these are a little bit different, because it's not two binomials. At least at first glance, it doesn't look like it is. My note to you is that you need to think about on something like this, what does it mean if you square something? Because right now I'm squaring this binomial, x minus 3. Squared means times itself. So my advice to you is it does not work to just distribute the squared. That's what people will try to do. but you miss a term if you do that. You have to multiply x minus 3 times itself. So you need to write this twice. People will go, like I said, they'll say, oh, let me just distribute this squared. That worked last unit when there wasn't a subtraction sign. Okay, if there's a subtraction sign, this trick doesn't work. People would write this, x squared minus 9. But you're about to see that this is not right. So let me show you why. I would distribute the x, and that would be x squared minus 3x. Then I'd distribute negative 3. And then I would go to combine these x's in the middle, and that would give me negative 3 minus 3 is negative 6x. So this is not correct because you don't have the middle term. Sure, you got the first and the last one. Maybe you're going to mess up the sign, I don't know. But realize that if you do not write it twice when it's squared, and it's like a binomial, you're going to leave out some terms. Okay, so think the same thing when you guys go and try f. Squared means times itself, so you need to write 7x minus 2 twice on this example. Okay, so you guys try those two. I'm going to do a few more with you here. Like I mentioned from the beginning, foiling only works first, outside, inside, last when it's two binomials. So if I give you something that's a binomial times a trinomial, something with 3 terms, you're just going to stick with that extreme distributing idea. Alright, so all I have to do is the terms in the first group, I just need to distribute those to the trinomial. So start with x. So x times 2x squared is 2x, add the exponents, that would be 1 plus 2, x to the third. X times x, it's just like 1 times 1, which is 1, and then you just add your exponents, so that would be x squared. X times 7 is 7x. Now take your negative 8 and distribute that through, and well, this is going to be a lot of terms, but that would give me negative 16x squared minus 8x minus 56. Hopefully you didn't write as big as I did. Oh well. So once you've multiplied it all out, then you look to see if you can combine anything, and I want to write my answer in standard form. So the cubed needs to come first, and I can't combine that with anything. I'm going to cross it off so I don't use it twice. Now the x squareds. So there's 1 there, plus negative 16 is negative 15 x squared. Then the x's, 7 plus negative 8 is negative 1x, and then minus 56. Alright, I want you guys to try h, just for the sake of time, and this video doesn't take forever. So you got 3 problems that I'm going to check next time. And I'm going to go ahead and do this geometry example at the bottom. This problem is really popular, I think because it just tests you on a lot of knowledge, and it's looking forward to next year in geometry class, which we've seen a lot of those examples this unit, so get used to them. This problem, though, it asks you to find the area of the shaded region only. So all this. So this is kind of different. You got to have a thought process here. Basically, you've got 2 rectangles going on. So here's what you're going to do. You're going to start by finding the area of the big rectangle, or the whole thing. And remember, for a rectangle, area formula is length times width. So let's start by finding the area of the whole thing. Pretend like the little one in the middle isn't even there. So I'm going to do length times width. Remember, we've seen so far this unit that if you've got like addition or subtraction problems as your length and width, you need to put parentheses around them. So I just got to multiply those 2 dimensions right there. So use your foiling idea. Oops. So you got like 4 terms. I'm just going to distribute the 2n through. So that would be 2n times 5n would be 10n squared. 2n times negative 2 is minus 4n. Then distribute the 6, and that would give me 30n minus 12. You can combine the n's in the middle. That would be 10n squared plus 26n minus 12. All right, that's the area of everything, this whole picture, but I don't want to include this white space in the middle, this smaller rectangle, so you're going to have to do a little bit more work. Don't stop if this answer is too big. So the first thing I need to do is find the area of this rectangle that's cut out in the middle. So I'm going to call that just the small rectangle. I've seen this problem before where they say like, oh, this is a picture frame, and we want to know like how much wood would I need to use to make the picture frame. So it makes sense in that regard. You'd have to find the whole thing and do something with the smaller rectangle in the middle where you would not put wood for the frame. So process is the same here. You just got to multiply length times width. Don't forget your parentheses. And I'm going to distribute the 3n. That's going to give me 3n squared plus 6n. Distribute your 2. Combine your n's in the middle. So here's the area of the whole thing. Here's the area of the non-shaded region. So if you don't know what to do from here, you need to take the whole thing and you need to subtract off what's not shaded. So I'm going to do this whole thing minus this thing. Group them together because now this goes back to a couple lessons ago when we did adding and subtracting polynomials. So remember when it was subtraction, we changed it to an addition problem. And then we changed the signs, and this pen's not going to work very well. We changed it to an addition problem. There we go. And we changed the signs of the second group. So basically I just need to make these all negative. I'm going to rewrite it so I can read this a little bit better. So just copy that one without the parentheses. Then it's going to be minus 3n squared minus 8n minus 4. And I just got to combine stuff. So n squareds, I've got 10 plus negative 3 is 7n squared. The n's, I've got 26 minus 8, which is 18n. And then negative 12 plus negative 4 is negative 16. Woo! A lot of work, but there's my answer.